document store the list in your retrieval, insertion and deletion in the middle. Okay, then what happens, it will create a problem. Okay, this is your list. Inside this list we have a object here, right? This all our object store here. So what happened, inside this you have stored the object, maybe A, B object are there, and it is working on the index, we know, right? Like anything, okay, till 0, 1, 2, 3, 4, 5, 6, 7, like that. So you are storing this, but if you will delete this line, right, then what happens, it will shifting operation will shift all the object one by one. If you have a like 1000 object, then what happens in this condition, it will take more time, right? Because internally it will shift. Okay, internally it will shift. So if you have a requirement like that, then we should not go for array list. So we have a concept called linked list. If you have a requirement for insertion or deletion in the middle, okay, then it won't be happen the shifting operation. If you will delete here, simply it will add this one. If you want to add something, simply it will add that place only. Okay, so it won't be happen shifting operation. So this is the major difference between array list and linked list. Why we will go for linked list, right? So this under data, the underlying data structure is the double linked list and doubly linked list. So it is developed on the linked list concept in the data structure. I'm not going to discuss this linked list internally data structure, but what is happening internally and why we use linked list and what is the difference between linked list and array list. Okay, insertion order is preserved, duplicates are allowed, heterogeneous objects are allowed, null insertion is possible, and linked list implement serializable, nullable interface but not a random access. So linked list best choice if you have an operation like insertion or deletion in the middle. Okay, if you have a retrieval operation, then we should not go for linked list, right? So these are the constructor of the linked list. Okay, create an empty constructor, here another constructor, you can pass any collection type, create an equivalent linked list object for given collection. Linked list class a specific method. So usually we use linked list to develop a stack and queue to improve support for this requirement. Okay, so we'll discuss on the stack and queue in the coming session. Okay, so define the following a specific method. So these are the method, right? Add first, add last, get first, get last, remove first, remove last. So we'll give you one example regarding the linked list. Okay, so created an object of linked list and storing this object here by using the add method. Here I use the set method. So set method, in place of 0 I want to add software, right? Okay, again in place of 0 I want to add Selenium, and I want to remove the last object. here we add the first. So like all the methods how to use this inside this linked list. So this is you can see here, this is your I have added this 4 object Java 30 and null Java. In place of 0 I set the software. This is your second. Now in place of 0 index I have add Selenium, and here we have removed the last object here. Again going to display, and I am adding this A as a first index. So like that you can perform the operation using linked list. Okay, so I have collected some point here. What is the difference between linked list and array list? So array list is the best choice if our frequent operation is retrieval operation, and linked list is the best choice if our operation is insertion or deletion in the middle. Then we should go for linked list. Just this point is the vice versa of this. Array list is the worst choice if your frequent operation is insertion or deletion in the middle, because internally several shifting operation performed, right? Linked list is the worst choice if frequent operation is retrieval or order. Okay, so same thing here. In array list the element will be stored in the consecutive memory location, hence a retrieval operation will be become easy, right? Simply it is going to store the object, but linked list having the won't be stored consecutively memory, right? It is working on the linked list concept. So linked list having a very complex operation, that thing I have mentioned. So mostly in collection they will ask the difference and where we will use this. So all the difference I have collected and mentioned here. What we learn here, so this is your collection list, 2 classes done, array list, linked list. Now what is vector? So vector is your legacy class. It is like a array list only, but it is a legacy class. Many methods is not present in the vector. Okay, so we'll see that, right? So we have already discussed regarding the difference between array list and vector. So vector is synchronized, it is a non-synchronized. Multiple thread allowed at a time in the array list. Here only one thread is allowed, so performance is less, right? So what is vector? So vector is like an array list only, but it is a legacy class. So underlying data structure is resizable array and groupable array. Insertion order is preserved, duplicates are allowed, heterogeneous objects are allowed. Null insertion is possible if it implements serializable, clonable and random access interface. Every method present in the vector is synchronized, and hence vector object is thread shaped, right? So this is the point. So if you will create this is your constructor. So if you will create a vector object, so default capacity is only 10, okay, but if you will increase this capacity, then current capacity into 2, it will increase the new capacity. So create an empty vector object with initial capacity is 10. Once vector reaches a max capacity, then new vector object will be created. This is your vector and initial capacity. Create an empty vector object with a specified initial capacity. So here we can pass the direct capacity also. Here you can pass the initial capacity and incremental capacity also. Here you can pass any collection. So these are the constructor which is available inside the vector. And we have a method like add method. Here we can pass here object and index and object add elements. So these are the methods, and this is also the method remove element, add, clear. So many methods are there. Okay, many methods are there, right? So we have a get method. Okay, so get element, add, first element, last element, size, capacity, enumeration element, right? So let's see, we have some example of this vector also. So created an object of vector, we are finding the initial capacity, adding the element in object inside this vector, right? 0 to 10. And here, after increasing this capacity, right, I have increased this capacity. Sorry. Okay, so new capacity will be generated, and again printing this value. Got it, right? So here the new capacity is generated, and all the value we are printing here. That's it, 10, right? If I increase the capacity into 2, it will increase, and all the object here as 2. Got it, right? So this is your vector. We have a stack. So stack is your this is your stack. So we have a core implementation class, we learn this stack. So it is the subclass of vector only, and it specially designed for last in first order. So created a constructor for a stack. We have a method inside this stack: push method, pop method, pick method, empty method, okay, and search method. So we'll see that all the methods. Push method means we can store push by using push method inside this object inside this stack. Right, ABCD. Now we have a method called search method. So search method will return return offset if element is available, otherwise return -1. Got it, right? So what you are doing here, I am going to give A, then it is returning the offset. Offset is nothing but, you can see here, this element starting from this value is printing, like this is the how many objects are there? 4. If you will use B, then the value will come 3. So this is called offset. If element is not there or object is not there, then it will return -1. So this is how search method is working. Pop method. Okay, so pop method will delete this. So what is the use of this pop method? To remove and return the top of the stack. So it will remove the top of the stack. So top of the stack, it is removed, this pop method. Okay, and we have a pick method. What is the use of pick method? So pick method to return top of the stack without removal. It will return top of the stack without removal, but this all the things you should in the real time not required. Just all the value you will get all the object. But these are the collection is not used too much. But if you might use if you will get some project or they have used this type of the collection, right? So that's why I am covering all the things, and you should also do the practice. Don't ignore this anything. Okay. So this is your stack. Okay. Next topic is your cursor. What is the use of cursor? So if you want to actually in the collection, the many concept is working on your hashing algorithm. Hashing algorithm means this is one container or object. So set is working on the hashing algorithm. It is not working on the index, right? But you have to retrieve this object, right? Then how to retrieve this? We cannot perform for loop here because this is the object and every object having the hash code, right? So the collection have developed one concept called cursor. Okay. So what is the use of this cursor? We will take the object one by one. Okay. We will take the object one by one. This is the one big bucket. In this bucket we have a multiple object. We are checking object is there or not. If object is there, we will get it. So if you have an operation like a hashing algorithm, then we should go for cursor. First we have to understand why we use this cursor, right? So cursor concept, why we use, if you have a hashing algorithm, right, then we should go for cursor. If you want to get object one by one from the collection, then we should go for cursor, right? There are three types of the cursor available in Java: enumeration, iterator and list iterator. So enumeration is your legacy cursor. It is applicable for legacy classes, right? So we can use enumeration to get object one by one from the legacy collection object. We can create enumeration object by using elements method for vector class. So enumeration is your interface. See what is enumeration. All the enumeration is your interface available in interface eTool package. An object that implement enumeration interface generate the series of elements one at a time, successive call to the next element method, and return the successive element of the series. For example, print the element on the vector. Got it, right? So enumeration itself having what is it? It is an interface, right? So we will see that. So we have two methods inside this: has more element and next element. So what is the use of has more or next element? We'll see that. Okay, so this is your interface referenced variable, and here we have a vector, any vector referenced and elements method. Okay, how to use this? So we have a has more element and has next element. Okay, I added 10 object inside this vector. Inside this vector I have a 10 object and I want to iterate, or I want to perform this enumeration. How to perform this? So this is your interface referenced variable, and this is your vector, any any legacy class. So here which legacy class is there? Vector legacy class. So this thing I have mentioned here, right? B dot elements. So we are going to access object which is available inside this vector class. Okay, now performing operation. So here we have used while loop, right? We provide the looping, right? So what happened? This object has element will check. Okay, object is there. Okay, so has where it is. So has more elements. Go through once this documentation. What is the use of this? See. Test if the enumeration contain more elements or not. Got it, child? So it will check contains more element or not, or object or not, and has next return the next element of the enumeration. If this enumeration object has at least one more object to provide, simply it will go and check it. So object is there or not. Object is there, we'll get this object, and next method will move this cursor to next object. If still there, then we will get that object. Again it will move the cursor for the next object. Okay, so here what is going to happen? So has more element will go and check object is there, will get that object, and again it will also check this has next element. Okay, has next element, just move the cursor if object is there. Okay, so this is how it is working. While loop. Why? Because while loop we are going to iterate. Like we have a 10 object, it will perform the operation till 10 object. If there is no object, then loop is terminated, then control will come outside the loop. Okay, here we perform the casting. Why casting we perform? Because this is your integer type, right? So we have converted into the integer type, right? Okay, and here just putting down the condition, printing the even value. If you add value, if you odd object is there, then it will remove this. That's it. So this concept is applicable for all the enumeration. Okay, so this is getting this object 0, again 1 will be removed, again 3 will be removed, because we are until unless we are getting this only even number. So this is output how it is coming, right? So this is how to perform the enumeration concept or cursor concept in your collection. So but we have some limitation of enumeration. So what is the limitation? So we can apply enumeration concept only for legacy classes, and it is not a universal cursor. While enumeration we can get only read access, we cannot perform remove operation. To overcome limitation, we should go for iterator. Okay, so this enumeration concept we have some limitation. So what limitation is there? Limitation is there, it is applicable for only enumeration. Okay, so just going to stop your session. I